All right. Today we're doing Pythagorean Theorem. This is a great chapter to go off of chapter 10 because there's kids struggle so much. All right. So it's a great one to come off of because it's pretty easy and it's familiar. So we use Pythagorean Theorem for right triangles only, not just any triangle, a right triangle. And the properties of a right triangle, they have three sides. And two of the sides connected to the right angle are called what? Does anybody remember? They're called legs. So the two sides connected to the right angle are called legs. And the one side opposite the right angle is called a what? Hypotenuse. Everybody say hypotenuse. So the thing about the hypotenuse is that it is always the biggest side. So it's always opposite the right angle, and it's always going to be your biggest. So whether they give you numbers, you will always look and see the biggest number is going to be your hypotenuse. Okay? Or whether they give you a diagram. Now we temporarily use these variables to create what's called the Pythagorean theorem, and that is a squared plus b squared equals c squared. Now, for the purposes of our school, we're going to be using those variables, and when you see a squared plus b squared equals c squared, they are talking about the Pythagorean theorem. The a and b, they're interchangeable. I could call a b and b a. Doesn't matter. What's not interchangeable is the hypotenuse. Okay, and so the formula goes like this. It's always leg squared plus leg squared equals the hypotenuse squared. Okay, leg squared, oops. So we do leg squared plus leg squared equals the hypotenuse squared. Okay? So these, again, are interchangeable. It doesn't matter what you call A and B. It matters what you call C. So here's how it works. Given a triangle, I always start with my formula because I'm in high school math and I need to show that I can utilize formulas. I start with my formula. Oh, it's a right triangle. Now, nobody's going to be like waiting for you to walk down the street or waiting for you and start and shoot down a formula at you. You see that right triangle and you're looking for a side length. You should say, oh, it's time to use Pythagorean theorem. God is not shooting that at you when you need it. Okay? So you just have to look at what you're set up for. I'm set up for a right triangle. I'm missing a side length. Oh, this is a good time to use the Pythagorean theorem. So I substitute my legs. Mandy, what am I substituting in?
So for a squared, it would be 6 squared.
And for b squared?
8 squared.
And for c squared?
X squared.
Perfect. And then we square. 6 squared is 36. 8 squared is 64. We add those together and solve for the x. Now what would I do? Don't be rude, just root it. Root both sides. Square root of 100. And what is the square root of x squared, please? No.
Absolute value of x.
Thank you. It is the absolute value of x. So if we're doing irrational equations, you've got to put that down. In this case, that means that I'm going to have 10 or negative 10 are my answers. However, Justin, we can't have negative measurement, so in this case, we'll negate our absolute value. But I kind of want you to do it and then just cross it out. I want you to be in the habit. I guess you don't have to. You can just solve for the principal root. Okay, so we know that our missing side, our hypotenuse, is 10 units. Okay, questions? Okay, now pause the recording and you try the next one. All right, now let's check our work. So we start out with a squared plus b squared equals c squared. Remember, our a and our 4 and 7 are the legs. So you had 65. We take the root of both sides. And now, what did you estimate it to be? Jesse?
I got 8.1.
Beautifully said. Now, as soon as you estimate, guys, I want you to put that about sign because it's highly inaccurate. I'd really like you to do 2 answers, a reduced radical and an estimation, because you're going to need both, okay? So in this case, radical 65 is the reduced radical. 8.1 is your estimation, about 8 1/10. Okay, questions? Yes.
With the reduced thing,
Radical.
get reduced radical.
Okay, you guys try the next one. Go on.
Would it just
Okay, what are we doing here? Okay, Drew, what am I substituting?
So you would do 6 squared plus t squared equals 15 squared.
Good. So now this time they're giving us the hypotenuse. Make sure you're paying close attention. Just because they give you 2 numbers doesn't mean they're giving you 2 legs. That was the hypotenuse. We have to put it in. The biggest number always goes in for C, or the hypotenuse always goes in for C. Is substituted in. And then we are going to subtract 36. And then we say t squared equals 189. Now, once I root it, 189, isn't that equal to, I'm looking at it right away, 18 is divisible by 9. 9 goes into 18 2 times 20, and then 1 more for that 189, right? 2 goes into 180 20 times, plus 1 more. So that would be 3 rad 21. You guys understanding that? Hannah, are you clear?
Yeah, I think so.
I just said 9 goes into 189. Goes 2 and 1. Right? So I did 9 and 21. The root of 9 is 3, so it's 3 rad 21. Or radical 189 falls between 169 and 196. 196 is 14. This is 13. This is about 13.8, 13.7. I will be okay with that. I like closest tenth. Round to the nearest tenth. As soon as you round, you have to put the about sign. Yes. Yes. And I don't want you to use calculators because on your test, you won't have a calculator. So you have to be able to estimate and you have to be able to simplify your radicals. So I'd like you to do both. Yeah.
So when you simplify the radicals, would you
You can take,
3 rad 21, you find the radical of 41?
you could do that and multiply it by 7. I think it's easier to find this.
Yeah.
Right? Now, when you get big numbers, I had a girl say to me, but we have big numbers. You can't do that. We had 5,000. Well, that's when I start going with 20 times 20 is 400, 30 times 30 is 900, 40 times 40 is 40 times 40 is 1,600, 50 times 50, 2,500. So if I'm close to like 5,000, or let's say it's 5,280, right? 52 is between 64, 80 times 80, and 70 times 70. Okay, now I can kind of round it down, take it down to is it less than halfway or more than halfway, and narrow it down to 5 different numbers. So 52, if I were doing 5280, right? Okay, that falls between 4900, which is 70, oops, and 6400, which is 80. Is it closer to 6400 or closer to 4900? So now I've narrowed it between 70 and 74. Do you understand that? If it were closer to 6400, I do 70 squared. Obviously not. Now I've really narrowed it down to 71, 72, 73, 74. That's 4 numbers I have to try out of all the numbers. Do you see? So don't worry about the big numbers. Work through it in your homework. Does that make sense? And then at the end, you can check it with a calculator if you want. But if you're within, again, remember, we're estimating. Mathematicians never do this. They always keep it in radical form because it's far more accurate. They never estimate. Okay? All right, so now let's move on. Let's go. Okay, one way they could ask us about a Pythagorean, yes?
I was just wondering, so you want us to do both?
Yes, I would like you to reduce your radical and estimate it to the nearest tenth.
Okay.
Try.
Yeah.
Yeah. Okay. Why don't you stay in at lunch and we can work on it a bit?
Yeah.
The estimating part. Okay. Here's one way that they could ask us to determine whether the given lengths could be the sides of a right triangle. Right? Here's 3 sides. Is this a right triangle? Well, we substituted into Pythagorean Theorem. If they give us side lengths, I input it. 5 squared, 12 squared, 13 squared. Okay? 5 squared would be 25. 12 squared is 149. 13 squared. Okay, 25 and 144 is? See how they're equivalent? When they're equivalent, it means it's a right. These are lengths of a right triangle. If it works in Pythagorean Theorem, it is a right triangle. If it doesn't work, we say no, it's not a right triangle. It's probably just a regular triangle. Is that clear? All right, so let's try the next one. You guys try the next one in Pythagorean Theorem. Go. All right, so what am I substituting for my a squared plus b squared equals c squared? How about Ashley?
So you're going to do 9 squared plus 12 squared equals 6 squared. Wait, 9 squared plus 6 squared equals...
Yes. Don't just because they gave it into you this order. Remember, our biggest number is always substituted for the c. Got it? And we have 81 plus 36 is 144. 81 and 36 is 117. Now, if you get it right, even though you did the wrong work, you still don't get credit. Got it, Ashley?
Yes.
So just make sure that biggest number gets substituted for the C. Is everybody clear on that? All right. Another thing we need to know about are our Pythagorean triples. There are special numbers, 3, 4, 5. 3 squared plus 4 squared plus 5 squared is a right triangle, where your legs are 3 and 4 and your hypotenuse is 5. One person said to me, can I get rid of the square? Does 3 plus 4 equal 5? So we can't. We can't just do A plus B equals C. So if I take this Pythagorean triple, 3, 4, 5, and I multiply it by 2, what do we get? 6, 8, 10, right? That 2 is a right triangle. If I multiply 3, 4, 5 by 3, that 2 is a right, that is a right triangle. If I multiply it by 4, by 5, by 6, do you understand? So 3, 4, 5 is my first triple. We can go on and on. Another Pythagorean triple is 5, 12, 13. And you'll see these going around all the time. So 5, 12, 13. All right, 5, 12, 13 is double it, 10, 24, 26, right? Triple it, 15, 36, 39. You get the idea? So if you just really learn 3, 4, 5, 5, 12, 13, and here's another. There's others too, by the way. 7, 24, 25, double it, triple it, quadruple it. These are all Pythagorean. And you know, these numbers come up all the time in math. They're like patterns that they'll keep using in all the math books. Do you understand what I'm talking about with the Pythagorean triples? Okay. All right, now we're going to do a proof. Okay? This is going to be kind of hard to write down, so I want you to just pay attention. We're going to talk our ways through it. Now, generally, when you do a proof, you do a 2-column proof. It's a formal proof. It looks something like this, where you're showing all your math work on the left side, and the other side is you're going to give us reasons, and you're going to reason with mathematical properties. So this side, we would do the reasons, and over here, we would write the steps in mathematics, in math. Does that make sense? But we're not doing that. We're going to just talk our way through. All right, I'm going to make a square. We in agreement this is a square? Okay. Now, inside that square, I'm going to inscribe another square. That means draw another square within the square. Okay. Now, notice what shape this has created here. What shape is that? Oh, so if that's a right triangle, we would say that our right angle is right here, right? So if that's the right angle, what do you think we can call this right here? Or A. And if that's A, what's this? And if that's B, what's this? C. Okay. Now we can obviously see that these two are not the same, so what do you think this is called? B. And this would be more like A, and this would be C. So what would this one be right here? And this? And this? And here? A, C. And you can see that this whole side is really made up of A plus B. Okay? All right, so we've named it. Okay, now that center area, what measurement would the area be? How do we figure out area? Right, side times side. So what would it be? C squared. We're in agreement. It's called C squared. Right? Okay, what happens? So we're saying the yellow area is C squared. Right? What happens if I take my purple triangles out? Right? Can I say that these two triangles make a rectangle? Right? Okay. And these two triangles make a rectangle. Now, if I take that out, and then I want to put them back in, but just in another area. You with me? I want to put them back in a different area in a different order. You guys clear what I did? I pulled it out. I'm putting it back in. And I'm going to do the same thing with the other one. Okay? Now, what is the measurement of the first white area? Yes. What is the measurement of the first white area right here? Okay, that's what we would call, how did you get that? Side times side, so we get a squared. And what is the other white area? B squared. Right? So, didn't we say that those other two areas made up the entire yellow area? But you said it was a squared and b squared. But what do we know about a squared and b squared? Yes, they do. So now we've just proven Pythagorean theorem. One more time. I'll go back really quick. We first inscribed. You don't have to write it. I'm going to show you a different one too. First we inscribed. Okay? We named all our sides. A, B, and C. We pulled out the little, we called the inside C squared because C times C is C squared. We pulled all the rectangles out. Triangles, sorry. And then we put them back in a different shape, different order. And then we found that same yellow area now became also a squared and b squared. So when we added them up, a squared plus b squared still equals that c squared. You guys right? Yes.
So if you were to calculate what c squared actually was, would you just find the hypotenuse of two rectangles, multiply them by each other?
Okay. Let me just finish this second one. Okay. In this case, I mean, we can't ever figure out what it is here if we don't know any measurements. We can't just...
Yeah, no, if we get measurements because before it was wrong.
Yes, well, we have a whole nother section. Hold on one second. So, if I take the total area of the whole square, and we have the purple area, right? The total area, subtract out the purple area, we should get the yellow area. Am I right? Now, isn't the purple area, isn't that made up of 4 triangles? And what's the formula for a triangle? Half base times height, right? Okay. And the yellow area we know is c squared. But if I multiply out a plus b squared, that's a perfect square trinomial. It equals a squared plus 2ab plus b squared. And then if I multiply this, I get minus 2ab. And we can see that the 2 cancel out. All right. Hold on. I have one more thing. Sorry. Yes.
Are we going to have to do this?
Okay. So for tonight, we're also doing 3 problems on the distance formula. The distance formula is used when we want to find a measurement of a diagonal on any coordinate plane. This you have to write. Okay? So just like, I'm going to just jump to it. You know what?